Hi everyone! Today we're going to be talking about perpendicular bisectors, angle bisectors, and right triangles. Our objectives for today are that students will be able to use the perpendicular bisector theorem and its converse, use the angle bisector theorem and its converse, and you'll be able to identify parts of a right triangle and apply the Pythagorean theorem. We've got lots to learn today, so let's get started. Alright, so let's first talk about perpendicular bisectors. The perpendicular bisector theorem tells us a couple things. So first of all, if a point lies on the perpendicular bisector, so perpendicular means forms a 90-degree angle and bisector means cuts it in half. So if a point, let's say point C, lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So if C lies on the perpendicular bisector, then we know that it is equidistant from both endpoints of the segment. So therefore, if we know that C lies on the perpendicular bisector, so if CD is perpendicular to AB, and we know that AD is congruent to DB, then we can say that the distance from C to one endpoint, A, is going to be congruent to the distance from C to the other endpoint, B. So then we can say that AC is congruent to BC. All right. Then the converse of the perpendicular bisector theorem. So the converse of the perpendicular bisector theorem tells us that if a point is equidistant from the endpoints, so if we know that C is equidistant from A and B, then we can say it is on the perpendicular bisector of the segment. So if we know that AC is congruent to CB, then we can say that CD is perpendicular to AB, because then we know that it is on the perpendicular bisector. So then we can say that CD is perpendicular to AB, and we can say that AD is congruent to BD. All right, because then we also know that it's a bisector, so it cuts the segment in half. So the converse is just the opposite of the perpendicular bisector theorem. So perpendicular bisector theorem tells us that if we know this is a perpendicular bisector, so if we know that it forms a right angle, it's perpendicular, and we know that it cuts the segment in half, then we can say the distance from C to A is congruent to the distance from C to B. So then it's equidistant to both endpoints. The converse, the opposite, tells us if it's equidistant to both endpoints, then we know this is a perpendicular bisector. So then we know that CD is perpendicular to AB and that it cuts segment AB in half. So AD is congruent to DB. All right, we got to keep them straight though. Let's keep going. All right, so now we're going to use the perpendicular bisector theorem and its converse to help us solve some problems. So first of all, we know that this point right here, this line is a perpendicular bisector because it forms a 90-degree angle and it cuts this segment in half. So therefore, we know that from this point that lies on the perpendicular bisector to both endpoints is going to be congruent. So we know that this distance is equal to this distance. They're congruent segments. So what we can do is we can say 7x plus 24 equals 13x minus 48 because we know both of those sides are congruent. And we can solve for x. So subtract 7x from both sides, add 48. We get 72 equals 6x, divide by 6, and x equals 12. And we solved for x. All right, number 3 is the same idea. So if we know that this is a perpendicular bisector because RT is perpendicular to QS and T is the midpoint of QS. So therefore, RT is a perpendicular bisector, so we can say that RQ is congruent to RS. Now our goal here is to find RS, but first we have to solve for x. So in order to solve for x, we would say 7x minus 22 equals 4x plus 5. Move all the x's to one side. Add 22 to both sides. we get 3x equals 27, and x equals 9. Now our goal is to find RS, so we want to plug it back in to 4x plus 5. So RS equals 4 times x, and we know x is 9, plus 5, 36 plus 5. So therefore RS equals 41. And we're done. All right, so number 5 is a little different. Number 5, we're given that from this point that hopefully will lie on our perpendicular bisector, we know that from C to B and from C to A, that is equidistant. So for the distance from C to both endpoints is equidistant, it's the same distance. Therefore, we can say that C lies on the perpendicular bisector. So if CD is a perpendicular bisector, then what we know is that forms a 90-degree angle, and we know that it's a midpoint. So we know that AD is congruent to DB. So therefore, in order to find x, we can set 5x minus 11 equal to 3x plus 17. Now we can solve for x. So subtract 3x from both sides, add 11. We get that 2x equals 28, divide by 2, so x equals 14. Now our goal is to find AB. So AB is going to equal this plus this. So what we need to do is plug x in for both of those. Well, we can say this plus this equals AB, right? That would be correct. Or we can just plug it into one of them and times it by 2. All right, so that's the method. We can do it either way, but what I'm going to do is just plug it in for x both times. So we're going to say that, let me get some more space here. So we're going to say that 5x minus 11 plus 3x plus 17, that's what AB equals, all right? Because we're adding segment addition postulate. We're saying AD plus DB equals AB. Then we want to plug 14 in for x every time we see it. So 5 times 14 minus 11 plus 3 times 14 plus 17. So over here we get 70 minus 11, all right, and we can leave these in parentheses if we want, plus 42 plus 17. Over here we get 59 plus, over here we get 59, and that's correct because they should be congruent. So AB equals 118. And we're done. So always be sure to read the problem and know what it's asking you to find. Is it asking you to find x? Is it asking you to find a certain segment? Know what the problem is asking you to do. All right, now we're going to be talking about angle bisectors. So the angle bisector theorem tells us that if a point is on the bisector of an angle, so if D lies on AD, and we know AD is a bisector of angle BAC, then point D would be equidistant from the sides of the angle. So if AD bisects BAC, and we know that AB is perpendicular to BD, so these two right here are perpendicular, and AC is perpendicular to DC, then we can say that BD, this distance right here, we can say that BD is congruent to DC. So we know this is congruent to this. So if we know that a point lies on an angle bisector, then it's equidistant from the sides of the angle. So then we can say that BD is congruent to DC. Now the converse of this theorem is that if a point is on the interior of an angle and it's equidistant from the sides of the angle, so we're given that this distance right here is equal, then we can say the point is on the angle bisector. So if we know that BD is congruent to DC, and we also know that they're perpendicular, so we know that AB is perpendicular to this and AC is perpendicular to this, then we can say that it's an angle bisector. So then we can say that angle BAD is congruent to angle CAD. So formally what we would write is, if we know that the point is equidistant from the sides, that's this right here, and they're perpendicular, then we can say that AD is an angle bisector, or AD bisects angle BAC. And then what this tells us, if we know that AD bisects angle BAC, then we know that the measure of angle BAD is going to be congruent to the measure of angle CAD. All right, so that is what we can determine from the converse of the angle bisector theorem. All right, so example number 1. We're given that the angles are congruent, so that means that this right here is an angle bisector. And we know that from this point to here forms a 90-degree angle, so it's perpendicular to both sides of the angle. Therefore, we can say the distance from the point on the angle bisector to both sides of the angle are going to be equal. So we know that this distance is congruent to this distance. Therefore, in order to find the value of x, set these expressions equal to each other. So we would say 9x minus 5 equals 4x plus 30. Subtract 4x from both sides. Add 5 to both sides. Cancels these out, and we're left with 5x equals 35. Divide both sides by 5, and x equals 7. Alright, so I want you guys to try to do number 3 on your own. Remember, you're not just trying to solve for x, you're trying to find the measure of AD. So go ahead and give this one a try. When you come back, I'll have the answer written on your screen and we'll go through it together. Go ahead and pause your video now. Alright, so you should have gotten that AD equals 35. How did we get that? So first of all, we know that DB is an angle bisector of angle ABC. So it's an angle bisector, and it's from here to here and here to here are perpendicular to the sides of the angle. So therefore, the distance from D to both edges of the angle are equal. So AD is congruent to CD. So what we can do is set these equal to each other to solve for x. So we do that, we solve for x, and we get 3. But we want to find AD, so we need to go back and plug it into 13x minus 4. So we plug 3 in for x into 13x minus 4, and we get that AD is 35. If you have any questions on this, please be sure to call me over. Otherwise, let's keep going. All right, number 5. Number 5 is asking us to find the measure of angle FGH. So what we need to do is look at our diagram and try to interpret what we're given. So first of all, we want to know, is IG an angle bisector? So what we need to determine is from the distance from point I to F and I to H is congruent, so we know that it's equidistant. And we know that IF is perpendicular to FG and IH is perpendicular to GH. So therefore, because they're perpendicular and equidistant, we know that IG is an angle bisector, so we can say that these two angles are congruent to each other. So what we need to do is set 2x plus 20 equal to 5x minus 37 since the angles are congruent, and then we can solve for x. So 5x minus 37 equals 2x plus 20. Subtract 2x from both sides. Add 37. We get that 3x equals 57. Divide both sides by 3. So x equals 19. Now the problem's not asking us to solve for x, it's asking us to find the measure of FGH. So FGH is this whole angle right here. So what we need to do is we need to plug it back into either one and then multiply it by 2. Alright, so if we plug it back into 2x plus 20, right, we plug 19 in, so 2 times 19 plus 20, 38 plus 20. So the measure of FGI is 58. Now, because we know they're congruent, this one's also 58. So we know the measure of FGH is going to be 58 plus 58, which gives us 116. So the measure of angle FGH equals 58 plus 58, or 116 degrees. Alright, so the last thing we're going to talk about today are right triangles. So what we need to know all the different parts of right triangles. So first off, we want to identify what are the sides called. So if we have a right triangle that looks like this, where we've got side A, B, and C, we need to know that sides A and B, the sides that are attached to the right angle, are called the legs. Alright, so those are the legs of your right triangle. And then the side that's opposite the right angle, so we look at the right angle and we go across from the right angle, that side is called your hypotenuse. And that in this triangle, that would be side C. So the side opposite the right angle is called the hypotenuse of your right triangle. Alright, and it's really important that we identify the different parts of a right triangle because we're going to be talking about something called the Pythagorean theorem. So what is the Pythagorean theorem? Well, the Pythagorean theorem is used to find a missing side length on a right triangle. So we can only use the Pythagorean theorem with right triangles. The formula for Pythagorean theorem is a squared plus b squared equals c squared. All right, and it's really important that we know that a and b are going to be our legs. And C is always your hypotenuse. So that's why we need to be able to identify the different parts of a right triangle. Alright, so for example, we need to find the missing side of each triangle. And we're going to get decimals, so we want to round to the nearest tenth. Alright, so here we're given that one of the legs is 8 inches and the other leg is 7 inches. So A equals 8. And B equals 7. C is what we don't know. Now C is the side opposite the right angle, so C is your hypotenuse. And we know C equals X. So what we want to do is use the Pythagorean theorem. We know A squared plus B squared equals C squared. And we want to plug in what we know. So A and B are both of our legs, so we want to plug them in. So 8 squared plus 7 squared equals, and C is our hypotenuse, and we don't know what that is. So we want to say X for C, so X squared. Then we want to simplify. 64 plus 49 equals X squared. Combine like terms, so 64 plus 49 gives us 113. Now, to get rid of the squared, because we want to get X by itself, what we want to do is take the square root of both sides. Because the opposite of squaring something is square root. So in order to do inverse operations and eliminate the squared, what we want to do is take the square root of both sides. So when we do that, on the right, we're just left with X, because anytime we're taking the square root of something squared, the squared and the square root go away. So we're left with X on this side, and we know that X equals the square root of 113. Now, we don't want to just leave it as the square root of 113. We want to plug it into our calculator and get an approximate answer. So we would say that X is approximately, all right, so those two little squiggly lines mean approximately. We put it into our calculator and we get that X is approximately 10.6. We're rounding to the nearest tenth to one decimal place. And because it's in inches, we want to put it back into the correct units. So we say that X is approximately 10.6 inches. All right, number 3. So we want to first be able to identify what are our two legs and what's our hypotenuse. So these are our two legs. So this is our A and our B. And our hypotenuse is the side opposite the right angle. So 13 is our C. So we want to use our formula A squared plus B squared equals C squared, where A and B are our legs. So we know that 6 squared plus X squared, because we don't know that second leg, is going to equal our hypotenuse squared, or 13. Then we want to simplify, so we get 36 plus X squared equals 169. Our goal is to get x by itself. So first subtract 36 from both sides. We end up with x squared equals 133. Now we want to take the square root of both sides. So on the left, we're just left with x. And we know that x equals the square root of 133. But we don't want to leave it as the square root of 133. We want to get an approximate answer. So we plug square root of 133 into our calculator, and we get that x is approximately 11.5 because we're rounding to the nearest tenth. And because we're dealing with centimeters, be sure to label it the correct units. So x is approximately 11.5 centimeters. Alright, so number 5 is the last example we're going to be doing today, and I want you guys to try to do this one on your own. So go ahead and give this one a try. When you come back, I'll have the answer written on your screen and we'll go through it together. Go ahead and pause your video now. Alright, so you should have gotten that x equals 16 inches. How did we get that? So first thing we want to do is identify which sides are our legs and which ones are hypotenuse. So these two right here are going to be our legs because they're the sides that are adjacent to the right angle, so A and B. And then C is always our hypotenuse. It's the side opposite the right angle, so 20 is our hypotenuse. We want to plug it into our formula, a squared plus b squared equals c squared, where a and b are our legs, c is our hypotenuse. So we end up with 12 squared plus x squared equals 20 squared. Simplify, then we want to move the 144 over, take the square root of both sides, so then we're just left with x over here, and 256 is a perfect square, so we end up with 16 even. So x equals 16, and we always label it with the correct units, so 16 inches. Alright, so I hope you learned a thing or two about perpendicular bisectors, angle bisectors, and right triangles today. If you have any questions, call me over so I can help you. Otherwise, look to the board to see what to do next, and I hope that you have a great day. Bye!